so now we've talked about how to calculate we need to calculate the surface area of this cuboid. So to calculate the surface area, we've got two lots of the front face. So it's 2 times 9 times 36 plus 2 times 9 times 12 plus one lot of the base, 12 times 36. So when it comes to calculating the surface area in terms of this shape, this front face, what is the area of the front face? So we've got 3x times y. What about the side face? 2x plus 2x y. And what's the area of the base? 3x times x. So putting the formula up like this, with brackets everywhere, I'm not wrong. I'm not wrong. So I've got the formula there. It says use this to write down a formula. So I'll get my first point. Unfortunately, this question knows that some YD teachers will say just write it like this. They then say unsimplify. So I'm afraid we're going to have to simplify it. 6xy plus 2xy plus 3x squared. Further simplification? 8xy. It's 3x squared. And this is in terms of xy. So there is our principal equation. There's our principal equation. So we're going to probably have to find the constraint equation next. So let's see what it says next. Write down and simplify an expression in x and y for the area of the cloth used to make Namco's bag. Write down.
Why is it x and y?
Oh, I've done D there. Yes. So that's D. Sorry. That's an expression for the area. We wanted to call it A. The first one was volume. So write down an expression for the volume. Now in this case, you're given your constraint. So this is the constraint equation. We're told that the volume is going to be this. So we need 3888 is equal to x times 3x times y. So 3888 is equal to 3x squared y. So this is still your principal formula that we're going to use, and this is your constraint formula. Because the volume is set, we're going to try and minimize surface area. So what you're asked for E is to use the parts in these two to get a formula for the area. So take your constraint and rearrange it to make y equals. What would we get?
How did you get 3x squared? Like, I know you multiply 3x by x, but how did you get that?
Volume. So volume is, if you remember back to the previous bit, we did volume by 12 times 36 times 9.
Yeah.
Length times width times height. So here we do length times width times height.
So could you go back
So
to
we
the
get x times 3x times y, which is here, x times 3x times y, which is 3x squared y. Mark it.
Could you go back to the 1 second?
Do we need to show the working out?
No.
Right.
The purpose of this too is to help you with the algebra in the next 3 questions.
Okay.
So doing it with numbers is often easier for students. When they're first trying to tackle a problem and get their head around the formulas, it helps them quite a bit, particularly that surface area.
So we could just recognize this one.
Yeah. Okay, so rearrange this equation for the volume to make y the subject. What would we get?
Y equals 3,888 squared.
Yeah. So if we divide through by 3x squared, we
It's
get
not negative 3,000.
Because it's not the derivative.
no, it's that we're not subtracting. We can only move the 3x squared down to the other side by division. Because what we're trying to do is move that down there move that to the other side. So we have a product here. So between the 3x squared and the y is a product. So the inverse operation of multiply is divide. So we have to divide both sides by 3x squared, which is why it comes under here, because this is divided by 3x squared. Yes. We are on E. So what we need now is we need to take this formula here and insert this. So we've got the area is equal to 8x bracket 3888 over 3x squared plus 3x squared. So we insert the constraint into the principal formula. Now look at this is the typical structuring for this question. It's saying use your answers to these parts to show that this is true. Well, look at the one we've got and look at the one we're after. They're similar, aren't they? Which bit are we done with? Mila, look at the two formulas. Look at the two formulas. We've got the 3x squared already. We need to make that number out of these. So we need to simplify. This x squared simplifies with this x. And if you look at where we're heading towards this. The last bit is try this on your calculator. You've got 8 times 3888 divide by 3. You've got 8 times this number divide by this number. What do you get?
10.4.
Give me all the digits.
10.368.
Look at this number up here.
Yeah, because it's this.
So this equals 3x squared plus 10368 over x. Now, the whole point in this is part E of a question. It gives you this bit so that you don't get stuck here. So you can continue with the next parts if you struggled with C, D, and E. You might have found that difficult, but always look for these questions where they say show that at a certain point, then continue after that if you find yourself getting stuck. So we're going to continue on. It now says we've got 3 more parts. That's another 8, 9 points maybe.
Wait, so can you quickly go back for 2 seconds? Scroll down, please. Thank you.
Okay, so what's the derivative going to be? Work it out for yourself. Work out the derivative. Do it, Kat.
6x minus 10,368x to the power of 2.
No, it's the power of 2.
Put it down.
Okay, over.
6x minus 10308 over x.
Yeah.
Make sure you mark it. Look at your piece of paper. Have you marked that as the derivative? So the way we do this, sounds good in this room, is you rearrange this one into this form, into exponent form, to the minus 1. Then we get 6x minus 10368 x to the minus 2 and then we put it back as 3x minus 10368 over x squared. Use your answer to part F to show that the width of the bag is 12.
Oh, you put that into the original dimensions, right? And
No. So what we've got here is Nanako decides to make a bag with a minimum surface area. So we need to find the value that will minimize this. We've got the formula here for the surface area. Sorry, where is it? We've got the formula here for the surface area. This is the volume for the surface area. So this question says, use your answer to part F to show that the width is going to be 12 centimeters. If you were to graph this, you could find that it's 12 centimeters. But the reason they say use your answer to part F is you can't do that. You have to use the derivative to do this. So you could simply sketch and you'll see the graph. The graph of this one is going to have to look something like this, where it goes down to a minimum value. And you could just graph it and find the value. That would work. But the structuring of the question says you have to use your answer to part F. So how can we find extreme points using the derivative? Make it equal to 0. So G. We need, our key phrase for today is to find minimum point, or all of the extreme point. To find minimum, let a dash of x equals 0. That's our key learning point today. We need can we use the polynomial root solver for this one,
Yeah.
Mr. Elbas? Can we use the polynomial root solver? Because x is at the bottom, so no. Then we have to use n solve. So n solve this.
So you can graph it as well, right?
You could graph this to find the roots. Graphing it is useful because it shows you how many roots there are. So with n solve, you could miss a solution. But when you graph this, you'll see very clearly how many times it crosses the x-axis. Unless you don't have your graph wide enough.
we graph the 6x minus 12.
12.
Oh, that's really the answer.
Yeah. Okay, the cost used to make her bag costs 4 yen per centimeter squared. This is where it's an interpretation. We've got this extra interpretation. So we need to calculate the cost of cloth used to make her bag. How do we do that?
Or not? No?
Multiply the surface area by 4.
Yeah.
So we need to find, in H, we need to type in 4 times A of 12. We need to find 4 times A of 12. This is where you have to realize that you have to put it into the 12, not into the derivative, but into the original function. And then times the whole thing by 4. So 4 bracket 3 bracket 12 squared plus 10,368 over 12.
Thanks. We get 1,200 points.
1,296.
96, yeah. Oh, I didn't have to put it right before.
Oh, yeah.
5,000.
Oh.
180.
Is there a question like he's gonna come on the major?
Yes. A little easier than this one. A little easier than this one. So
5,100.
5, 1,
Eight.
8, 4, something like that, isn't it? Yeah. Something like that.
Points that we like don't know about seasonal.
Absolutely not. You could give them back whatever they give you here, because they got to ask for it like in some way. So you give it back in whatever way they gave you. JPY would do.
We can go back first.
Okay, well, that's it. Let me finish recording. Have a good one.
Bye, Christian.
Bye, Christian.
Have a good day.